All right, so this, okay, so this will serve as the video for 5.3. So the question that we had, this is about exponential equations, and their differential equations are a little bit different. Instead of it being a function of time, now the derivative is actually proportional to the function itself, which is a little bit odd. So what we would like to do in this case is to get all the q's on one side. So dq over q, all the q's on one side, and then everything else on the other side. And now we're going to do the antiderivative of both sides. So what is this one? dq over q. What pattern is that? Anyone remember that one? Ln. That's a ln. Derivative of the bottom is in the top. That's a ln. So we have ln q on this side. What is the antiderivative of 7?
What's the
7, right?
7t. We'll go with t because we're t's. So this is just 7t. And then somewhere in there we have a plus c. Do we need to have a plus c on both sides? It's just a general constant, so we could combine them all. C1, C2, no, just put a c on one side. So now what was the whole point of this? Was to find q. So how do I solve this side for q? How do you undo a ln? Well, it is a log. How do you undo a ln?
Just 1 over q.
No. Pre-calculus. Squares and square roots undo, cubes and cube roots, lns and, yes, exponentials. So we're going to exponentiate both sides. So we'll get e to the 7t plus c. So when I undo the ln on this side, I rewrite it by doing e to the something on the other side. Now we can rewrite this as e to the 7t times e to the c. Are you guys comfortable with that? What I've done is I've said it's the same base. I can pull apart. I can pull apart those exponents. This, is that a number or is that a variable? That's just a number, right? E to the c. Whatever c is. I mean, I haven't pinned down c, but as soon as I know what c is, this is just a number. So in the end, I'm gonna call that something special. Q sub 0 is what I'm going to call that. Okay, so hang tight.
Well, I don't understand why it would not be, like, we wouldn't do prime, because when we did prime, it was like dy dt. It's the same exact thing, except we just changed the letter.
Well, no, because this is important. That wasn't there before. We had a t before. So if I do that, if I say q prime equals 7q, now what? Right, now I've said the derivative is proportional to the function itself. Do I have the function itself yet? I don't. So what we're going to end up with over here is we're going to have q of t is q sub 0 e, in this case, to the 7t. You don't have to do it this long way out the whole time. This is just where it comes from. It's not magic. So I don't like it when people think math is magic, because it never is. So here's the deal. If you ever have dq dt, so let me write the rule over here. So if you ever have dq dt, the derivative of the function is proportional to, that means it's some constant times the function itself. The answer to that is always an exponential, and it's always equal to this. So anytime the derivative is proportional to the function itself, the answer is an exponential. This is called the initial condition. Why would I call that the initial condition? Initial condition means what happens when t equals 0. If I put 0 in here, what do I get for e to the 0? 1. So when t is 0, it's equal to my initial condition. So let's do one problem. I didn't assign a lot of these problems, so not to worry. Let's just do one. Let's look at this problem again and just solve it directly. Actually, let me give you one. So, I'll give you. Let's look at number 40. No, 42. So we have the y dx, this is number 42 in section 5.3. It's number 42 on page 350. So we have dy dx equals 0.1y, and I know that y of 0 is negative 2.5. This is a differential equation because I know something about the derivative. This one's an exponential derivative equation, differential equation, because the derivative is proportional to the function itself. Remember what you're trying to find. You're trying to find y. If I had x over here, it'd be one thing, but I don't. I'm trying to find y. So that means that I know I have that form. I know it's going to be y equals some initial condition times e to the 0.1 x. It's just the format it fits. Do I have enough information to find this? I do. I have the initial condition, which means this is y sub 0. So my answer is, I can just put that in. That's it. Is that okay? This is a little bit of, I think maybe next time I'm not going to combine this concept with today. So, give these, I only assigned 3 problems in this section, so give them a go. The important difference is, so let me just draw this distinction. If you have this, that's normal. You take the derivative of both sides. This t is what you're taking with respect to. That's a normal antiderivative. So this is just b equals, raise it, divide by it, add c. What's different is when this letter is a b. So that's a less common equation, common situation. Okay, so.
What I don't get is like how on the last one, not that one, the one before it.
Yes.
How like you just like switch you switch the whole thing around, like you flip the dt or something to the other side. And, like,
Yes. I just want to show you where it came from.
Okay.
Let's talk about that. That's I don't want to spend a lot of time on that, so you and I can talk about that. Anyone else who's interested? Okay.